Hello, my name is Kaya Alyssa Brown. This is my journal club presentation. The research article I decided to take a look at is the hip abduction and abduction torque angle curve characterization of speed skating athletes. So a description of the study is essentially it focuses on speed skaters and essentially the adaptation, growth, and change of their muscles, specifically their hip muscles over time. So the whole purpose of this research study is that oftentimes there wasn't a lot of research that focuses on the musculature of speed skaters and how it changes and adjusts over time. So this article serves to gauge the growth, development, and functionality of these muscles, and also to measure the differences in peak torque angles, also referred to as this article as PTA, between skaters and non-skaters. So for the literature evaluation, the research paper itself acknowledges that there's not a lot of research that focuses on speed skaters and the growth and changes within their muscles. However, the article itself references a lot of studies that focuses on other sports such as soccer and running. So there's that. And then also it references literature that focuses on the software it uses it to process these EMG signals. It's called OpenSim. And additionally, the research literature includes animal studies, which also further illustrates just the lack of a lot of research in this particular field, that there are also animal studies that are referenced. More specifically, they are referenced on the change of the length of these leg muscles over time. So the subjects of this particular study are semi-pro speed skaters as well as a control group of healthy adults. The speed skaters had at least 2 years of experience and skated in both indoor and outdoor terrains. This is just to prevent any discrepancy through a skater who might particularly or solely skate on one particular terrain, which could have an effect on the results. Additionally, those who were excluded from the study include those with prior hip injuries, and this goes for both the control and the pro skater group. Additionally, sample sizes for both of those groups were 10 individuals, and there does not appear to be any strict biases between the different sexes and origins, although there is a very small sample size, so there's a possibility that some very important groups could have accidentally been excluded from the study just because of a very small sample size. And the participants for this particular study all were around 31 years old, which is like the mean average age of the participants, within like around 2 years of that. So the methods and designs of this procedure of this study includes this. So the procedure is that all the participants in both groups were instructed to perform a 50 abductor and adductor exercises while standing, and then they are placed in a chair with a dynamometer, and attached to them were 16 channel electrodes placed in various areas on the legs and hips. The participants then perform their abductor exercises beginning at 0 degrees and then extending their muscles to 45 degrees. Specifically, the participants performed maximal voluntary isometric contractions and maximal voluntary dynamic contractions test. And they did 6 sets of these, and in between each set, the participants had 30 seconds of rest. To continue on the methods and designs, the researchers did gain consent from all participants and received approval from the Institutional Ethics Committee. The study also meets the standards of the International Journal of Sports Medicine. As for the analysis, all the data was gathered through the EMG USB 2 device and then processed through a software called OpenSim. And through this, they also removed a lot of the peaks or any of the inconsistencies or irregularities in the data, and also the data was normalized. It was also shown that they got the average of the EMG value and found the standard deviation between the control group as well as the group of pro skaters. Additionally, ANOVA and t-test were performed. So the test was performed specifically between the EMG data and the TI data, which is the torque integral, and is proportional to the average muscle power delivered in one movement. And as you'll see in a second, these results did prove significant. So here's the results between the non-athletes and the athletes themselves. So you can see the difference between their results, both in the abduction and adduction. And that dotted line on both of the graphs indicates that there is a significant variation between the results of the two groups. And additionally, something that was very poignant in the research is that the peak torque angle did not differ between the groups of athletes and non-athletes. As you can see, both of the lines are very similar. So the thin line, the dotted line is the athletes, and the other line represents the non-athletes. And as you can see, that the results are extremely similar. So this is something that did not vary between the athletes. So let's go on to our results and discussions. So the findings were essentially that these the peak torque angles did not vary, as well as the peak torque amplitude. They were very same between these two groups, and as well as the isometric and dynamic peak values were the same between the two duels. However, these skaters tended to have a greater curve integral. So this greater curve integral is essentially very important for propelling the skater forward, and it's also very important for essentially giving the skater power to move in these movements. So the researchers essentially suggest that the finding shows the existence of musculoskeletal tendon actuator adaptations towards a better capacity to generate mechanical work and power during a propulsion recovery cycle. So another thing that the research also shows is that the non-skaters, while they are able to reach the same angles, they do not have the same amount of power and propulsion that the athletes would, which is quite sensical. However, the results at times were a bit difficult to decipher while reading this research paper and looking at the results. There are times where there were some things that there could have been clarity on. And limitations is that the dynamometer that the results were gauged from is that they do not cover the full range of movement that is used in speed skating. They mostly just focus on these hips and leg movements, so that could be a limitation. And there are also possibly other muscle groups that are involved with speed skating that could have seen a growth or difference between the control group. So the significance of the study is that the body can adapt significant muscular skeletal structure based on repeated and intense activation of muscle groups. This study also contributes to the body of knowledge because there's not a lot that focuses on this particular group of athletes, especially since it is a very different movement than a lot of other exercises such as running or playing soccer. Just the different muscles that are activated while skating and the intensity of muscles that are activated while speed skating. It's something that is not fully researched yet. The study appears to be replicable, but there could be variation based on the increased sample sizes. If someone were to do this in the future, essentially now it's a very small sample size, which it can be reproduced. However, there is a possibility that the results could vary significantly based on whatever sample is being drawn from. So some questions the study raises are: what other muscle groups are impacted by speed skating as it is a full body exercise? This is something that the research admitted as a limitation. Do other athletes also experience the same hip abductor and adductor growth? And why do speed skates and the control groups have similar values in peak torque amplitude? This is something that the article did not specifically go into, and I'm curious to why were these values exactly so similar between athletes and non-athletes. And this is the end of my presentation. Thank you for watching.